Today we are going to answer the question of what is an isotope? Okay, what is an isotope? All right, I'm going to use this diagram as some examples and so that we can figure this out, because all three of these tell us that these are isotopes of hydrogen, carbon, and magnesium. Now, using this, we'll be able to figure out and define exactly what an isotope is. So let's look at each one of these hydrogen atoms. Now I know that's a little small for you to see, but I'm going to talk you through it. All right, so this hydrogen, if we look at it in the nucleus, so this circle is what is actually in the nucleus, we have something that looks like a positive sign, one positive. So what is a positive? Well, we know now that a positive is a proton. So how many do we have? One. Now, when I'm looking at this, I don't see anything else. And we know that what is the other subatomic particle in the nucleus? It's the neutron. But if there's nothing else there, then that means I have no neutrons. All right, so now I'm going to look at this one labeled 2,1H, or hydrogen 2. Again, I'm going to look for the positives. Okay, I've got one of them. Positives are protons, and I have one of those. But then I also have something else, a little circle that has no positive in it. And they're saying that that is a neutron, labeled right here. So I have one neutron. And now I'm going to look at this last one, hydrogen 3. And when I look at the nucleus again, I have just one positive, and then I have two of these other circles, which are neutrons. So I've got one positive proton, and I have two neutrons. All right, so let's take stock in everything that we just saw here. So all three of these have the same number of protons. All three of these are named hydrogens. However, all three of these have differing number of neutrons. So now if we look at the mass number on this, remember the top number in our diagram, in our nuclear symbol, is the mass number. 1, 2, and 3. So our mass number is also different in all three of these. Okay, so let's look at the next example. Isotopes of carbon. All right, so I'm looking at my little thing right here. I've got 1, 2, 3, 4, 5, 6 little positives, and so that's our protons. And now I'm also going to look at these circles, 1, 2, 3, 4, 5, 6. So I've got 6 neutrons. Let me look in this next picture labeled carbon 13. 1, 2, 3, 4, 5, 6 protons here. And if I count the circles, 1, 2, 3, 4, 5, 6, 7. 7 neutrons. All right, now I'm going to look at this last one labeled carbon 14. 1, 2, 3, 4, 5, 6. Again, 6 protons. And neutrons, 1, 2, 3, 4, 5, 6, 7, 8. It's kind of hard to count. 8. So now let's take stock of this one. In these 3 atoms of carbon, still labeled carbon, still have the same name. They have the same number of protons, but differing number of neutrons, which ends up so that the mass number changes as well. The mass number in this one is 12, 13, 14. Also in hyphen notation, 12, 13, and 14. So as the neutron numbers change, the mass number changes, but still, it's still carbon because it has 6 protons. All right, now I'm going to look at this last one. And there's too many of these for me to really count. So I'm just going to look at the nuclear symbol to get our information here. So in our nuclear symbol, I know that the bottom number is the atomic number, and the atomic number is the same thing as the number of protons. So the atomic number here says 12. So I'm going to say, okay, so we know there are 12 protons. This one says 12 protons, and that one says 12 protons. We also know that if it's magnesium, I could look at a periodic table and see that the atomic number is 12, so that means 12 protons. Now let's check out the number of neutrons. Again, those are too small for me to count all those. So what I'm going to do is I'm going to use the nuclear symbol as a little subtraction problem to tell me my number of neutrons. 24 minus 12 is 12. So that means I have 12 neutrons. Now in this one, 25 minus 12 is 13. 26 minus 12 is 14. All right, so let's take stock on this one. Again, we have 3 atoms of magnesium. They all have the same number of protons, so it's all magnesium, differing number of neutrons. So we can see now all 3 of these were called isotopes. And so in all 3 examples, the protons stay the same. However, you have differing number of neutrons. And that is our definition of an isotope. So what is an isotope? An isotope is atoms with the same number of protons and differing number of neutrons. And the differing number of neutrons results in a differing mass number. Okay, that's what an isotope is. Let's read it one more time. Atoms with the same number of protons and differing number of neutrons results in a different mass number. All right, that's it for today. I will talk to you guys tomorrow.